Quality automation means the quality picture for the larger team. It means automation around measuring, recording, and communicating product quality and make it available for analysis across the larger team in an ideal way. So actually quality automation is an ideal, and MetaAutomation just shows a way to achieve that ideal. But I'm going to use the quality automation term. You'll hear it again. Paradigm shifts. More productive ways of viewing the problem domain that we face every day. Impact on roles, because with radically better communication about product quality, it impacts different roles in different ways. The 7 patterns of MetaAutomation, and I have a nice diagram. Problem solved. What the problems are that MetaAutomation solves. Some of them cannot be solved any other way, to my knowledge. And we'll see if you agree. But what you can do tomorrow. I do have a few things that I encourage you to do tomorrow to increase your effectiveness and productivity for software quality. No, but first, a little bit about me. So I'm hardcore nerd, like nerd. I have 2 degrees in physics, taught me how to think. I like hard problems. And it's just the labor of love. This has been my passion since I was doing quality automation on a team, and I realized that this could be much better than it is. There must got to be a better way to do this. And so the hard problem for me was finding a way to do this. And I'm an idealistic idiot. It would be so much easier to just do it the way that the state of the art says, this is the way it's done, just do that really well. But I was not happy doing it, because I did that, I tried that, but it just didn't make me happy, because I knew, like, oh, there's a better way. I wanted to do it better. My boss is not so much, but, so what do I ask of you? So, first, I have a question. How many of you are individual contributors on the team doing test automation or quality automation? Or have been that role? Yeah. How many of you think that, oh, this is good, but I know there's a better way to do it than current practices? So, cool. It's like a dozen. Okay. All of you who raised your hands, I believe you're right, because there's so much room for improvement relative to the way things are done right now. So, as I said, with MetaAutomation, I provide a vision to attain the ideal of quality automation. It's not the only way. I don't know of another way right now, but maybe you have one for your specific project. And feel free to ask questions. So I'm asking you to listen, keep an open mind. Please do ask questions. Think about the big picture. And I will talk about a few things that you can do tomorrow. I also have some books to give away, 2 books for really good questions. And I need to make a caveat. These books are, this is the 2nd edition of MetaAutomation, and it's the current version. It's also going to be outdated. In fact, it's outdated by this talk, because I introduced a new pattern that I wrote called Hierarchical Steps. And I'm defending it next week at the Pattern Languages of Programs Conference in Illinois. This book doesn't have hierarchical steps. It should, but the 3rd edition will. So I target February. But this book still has a lot of good stuff in it. So I have 2 of these to give away for really good clarifying questions. If I say something which is confusing to you, I need to clarify myself, and not just to you, but there are probably other people in the room that may be confused. So please stick up your hand or call it out the question. And I will have pauses for questions during the presentation too. Quality automation. So it's the ideal. How can we best measure the quality for the product and communicate it around the team and hold records and do analysis on what is the product doing? This is what we're all about, right? We're all doing this. But we have all been held back, and I say we, like first person plural, me too, have been held back by some historical accidents. The first is, in my opinion, test automation is a historical accident, and it's a mistake, because it's a contradiction in terms. When we say test, we often think of the manual test, which is often how people start. We write down a test, and I do this, this, and that. And it's a manual test. Now try and automate that. What you get is something different. So more on that. Also, automation, it started in the 50s with industrial automation, building stuff like widgets and car parts, and it's about the end product. With repeatable quality measurements, we don't care about the end product because the data is fake, isn't it? Other than the quality measurements, we don't care. People focus on the pass-fail result because it's easy to measure, it's fairly obvious, but we are dropping a lot of information on the floor that has business value about what is going on with the product as we drive it. So this talk addresses that. So I deprecate the term test automation as if I could do it all by myself. I mean, but quality automation addresses the larger team. Test automation takes the word automation, applies it to test, implying that the value is limited to the QA team, and that's where your value is going to be. But what I'm talking about today is the larger team, so everybody on the larger team. So the second problem, the point of test is to find bugs. Thank you, yes. Clenford Myers in 1979, he wrote that in his highly influential book on software testing. This is 1979, so ancient, and that's why his book is so influential, because it's been around a long time, right? So, and I would ask, who around here was not even born in 1979, but I might embarrass some people, so I'll tell you. I was 14 years old back then, and I didn't know anything. I sure could program a computer, though. Otherwise, I didn't know anything. But today, I'm here to tell you, Myers was mistaken, because bugs are great. We do have to find bugs and find where the product does not work to spec, where there are quality issues. There may be action items there. That's important. But even more important is we have to answer the question, does a system do what we need it to do? And what Myers said was, he was emphatic about this, we should exclusively look for bugs. But if that's what you're doing, how to find the most bugs, maybe you're rewarded for it. If that's all you're doing, you cannot answer the question, does a system do what we need it to do? Because you're looking somewhere else. Quality automation is not about finding bugs, but about answering the question, does a system do what we need it to do? And I'm going to repeat that phrase a few times because it's actually very important. It's the best way to do functional and performance quality with clarity, accuracy, and detail, and communicate it around the team and find value to project around the team, the value of what the QA team does. And enable robust analysis. And you'll see when the amount of pure data you can generate about product quality is great for analysis. Basically, you can do queries on what's the performance trend and what's the reliability trend and stuff. The 6 paradigm shifts. So one of the things I realized this for the second edition of my book, that I am asking people to, remember I was asking stuff of you? Sorry. I was asking people to look at things a little bit differently, because if you can take another perspective on the problem domain, you can sometimes be more productive. And I'm asking you to take a more productive view of the problem domain. We know about the conventional view, and I know you all do good work. Everybody here is delivering value to your teams. I'm suggesting that there's a more productive way to do it. And one of the ways I did this is say, well, come up with paradigm shifts, different ways of viewing the problem. Number one, quality automation delivers very different value from the manual test role. And I'm going to introduce you to 2 of your colleagues, Otto the automaton and Tara the tester. Otto personifies the quality automation function. Otto does automated measurements and verifications, communications, processing document, directing notifications, and holding the data for analysis. Otto does all that stuff for you. Basically, he is what you think of automated tests. Tara is the manual tester role. So Tara is a human, and she's smart, and she's observant, and she's a good detective, and she notices when things are out of whack. She can characterize issues and enter actionable bugs. She's smart, but she's also human, so she gets bored, and she gets tired, and she gets sick sometimes. She goes home at night, and she has a life outside of work. Everybody here, including me, everybody does Tara sometimes. And if you don't, you need to, because you cannot ship software without Tara. But I'm here to talk about Otto. Now, once you tell Otto, you have to tell him exactly what to do in great detail. Once you tell him what to do, he does it fast and repeatedly and with precision, tirelessly, and in the cloud, and across geographies. And he can handle detail far better than any person, and that's what computers do. So Otto the automaton is a persona for that role and what it can bring to your team. So my number one point about the value that I'd like you to take away with today is that, and you may already suspect this, but the value of Otto to your team and the value of Terra to your team are very different. They bring very different things. But Otto, have him do what he's good at, and you will deliver vast increases in business value to the team. And I'm talking about answering the question, does a system do what we need it to do, with the precision and the clarity and transparency, and putting that all out for everybody to see. Paradigm shift number 3. Checks are bounded in time. I use the term check when some people use automated test. And by check, I mean, yes, we're aware that this is automation. It's not a manual test. We're not smart like Terra, and we're not going to notice stuff because if we're Otto, we're doing a check. The verifications are explicit in the code, mostly explicit in the code, and that's what we're doing. So it's used with industrial automation, and the example I use is also from a utility. So you also use as a kind of automation. I pay my electric bill to Seattle City Light, and they have this big infrastructure for delivering their electricity. They have a lot of instrumentation, and it logs like this: log, 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 log. And the logs are uniform, and they have timestamps. And then they measure what's going on with the instrument, maybe the voltage or the current or the temperature of the instrument, but they're all the same, and they're unbounded in time. They go on for essentially forever or until the equipment is replaced, but we don't know when that is. It's continuous. Logs work for that. And I think that's how the tradition got started with the conventional automation, where we automate a test. People put in logs, but they're entered at different places in the code, and they mean different things. They're entered by different times or by different people or by different processes, and so they're heterogeneous. Log, 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 log. Despite the fact that for repeatable automation, it is bounded in time, and we know it's bounded in time. Conventional automation does not make use of that fact. MetaAutomation does, when we do quality automation with MetaAutomation, does make use of the fact that an automated verification is bound in time. And so, ding, it can do structure. I use XML because it's the most standard, it's very powerful, it's platform independent, and it's brilliant at what it does. More on that in a minute, but we have a structure, and that's how we use to describe what the product does, what the measurement is, and in fact, the entire structure of the automated verification, including the title, or the overall purpose. Paradigm shift number 4, hierarchical steps. I think I mentioned that paper that I'm defending next week at the Pattern Languages of Programs conference in Illinois, and this is foundational. It's not in the second edition of the book because I hadn't really characterized it yet, but I use it, and so it's in the software samples on MetaAutomation.net. Hierarchical steps pattern gives flexibility and robustness and transparency, and it gives you big advantages for error handling and for small changes in the procedure and the way it's recorded in pure data. Hierarchical steps is also a natural pattern of behavior. We all do it. Who here bought a plane ticket to come to PNSQC? Plane tickets, you bought it online through a website? Yeah, okay. So there's an example of hierarchical steps, although you didn't know you were following the pattern, but you were, because you have the overall purpose, you'll buy a ticket to fly to Portland. And then you have child steps. The first page, call that a child step, and it's where you say from where to where, the origin and destination and the dates of travel. That page then has child steps where departure date and return date and city of origin and city of destination. And the powerful thing here about hierarchical steps in describing the procedure is if you do this a lot, I imagine you do, buy plane tickets online, you know how to do it. You don't have an issue with it. It's not a mystery. But imagine telling somebody who has not ever done this before, maybe isn't even familiar with web browsers, and how do you do this? Then you have to get more detailed. And so you can add more detail in the child steps without disturbing the rest of the hierarchy. So pick a date of departure. How do I do that? Well, you click here and drag or use the control, or you enter day, month, year separately, and so on. You can add detail. It's one of the advantages. And if you have a failure, then the failure propagates up through the hierarchy. I couldn't buy a ticket because it wouldn't let me pick the right day. But the traditional pattern for automated test automation, is that you have a long list of steps. And if you had to add or change a step in the middle, it kind of disturbs the whole structure, which is pretty weak anyway. But if you have parents and children, it gives a structure to the whole procedure that you don't have otherwise. Another example is installing a kitchen appliance. Has anybody installed a major kitchen appliance in the last few years? Maybe, yeah? Yeah, good on you, all right. So I installed a dishwasher, and it's a nice dishwasher. It's a Bosch, and it comes with a pamphlet, how to install the dishwasher. There is your root of the procedure, how to install the dishwasher, and that's the title of the book. Inside is how to install a dishwasher. Inside you'll find the child steps. So first you unpack the thing, and you have to prepare the space. You have to hook up the plumbing, and you have to hook up the draining, and then you have to hook up the power for the dishwasher. So maybe this is second nature to you, and you don't have to know. In the case of my Bosch dishwasher, hooking up the power meant first turn off the power because I had to do some wiring. Okay, child steps. Turn off the power. Can anybody guess, what are the child steps of turn off the power? What do I have to do?
Locate breaker box.
Breaker box, yes.
Locate the specific breaker.
Yep, number 2.
Verify that it's really off when you do turn it off.
Flick it off and verify. Okay, there's 4 child steps there, but perfect. Yeah, so there's child steps. Now, to somebody who does this a lot, you don't care about the child steps, but they're there. They don't disturb the rest of the hierarchy. It's a way that it actually happens naturally. And so I have really glad I identified this pattern and, oh, it's an existing pattern, and apply it inside the pattern language. Although, even if I haven't identified it in the second edition of the book, it is implemented, and I'm going to reference the pattern, the samples, the software samples. My website is MetaAutomation.net. If you download and run the samples, there are 2 of them. They do lots of cool stuff, and one of the things they do is implement hierarchical steps without calling it that, because I didn't know about it yet to be discovered. Paradigm shift number 5, and I was discussing it this morning with a gentleman who faces this problem at work. Measure quality with multi-tier checks for the Internet of Things. So Internet of Things is, if you call it in general, the paradigm which includes you have devices talking to each other over some kind of a network. In any case, you have multiple tiers. It could be 1, 2, or many different tiers. And if your product crosses those tiers, you probably have a functional requirement or a specification that concerns multiple tiers. Well, now you can test it with 1 check, not 2, not 1 for each tier, and the other ones are faked out. You can do it with 1 check across all those tiers. And the way this is done is with the structure of the hierarchy, hierarchical steps again. And this is done in the samples on MetaAutomation.net. It's so cool because I cover many different tiers, and they're kind of fake, right? They're very simple in the way it's implemented, but it shows you how you can do this. And so you can do multiple tiers. I could have a Windows tier over here, and a Linux tier over here, and my phone over here, and they're all talking to each other. And because my samples are essentially platform independent, it will show you how to do this. Before I should probably talk about the source code, because I encourage you to take it, fiddle with it, noodle around, copy, port it over to Java if you want. It's C# on a free version of Visual Studio, but you can port it to any platform you want. I don't have a license on it yet, but that software is there just to exemplify what you can do. And paradigm shift number 6 is the last one. Better quality data empowers the whole team across geographies and across the SDLC. So how many of you are on a product where you have distributed teams across geographies? Yeah, 2 people. So I don't want to delve into communications issues, but I do know that, and I've done this, if you're crossing time zones, there's a little bit of a problem because you have to agree on a time to meet where everybody is awake and in the office. And then you may have language barriers or cultural barriers. People see things differently. Communication is not always easy. But if you have the quality of the product reported with great detail in that hierarchy, then at least you have something in common. The work of the QA team is very transparent because we know what we've automated here. It's here on the internet side. I can see the check or when the check was run, or maybe you have branches that different runs on, and I can drill down to all the steps, all the way from the business-facing step, business-facing interface of MetaAutomation down to the technology-facing. I'm a little ahead of myself because actually this comes up in the next slide, but I do want to pause and ask, are there any questions about,
So when you mention a MetaAutomation pattern, language pattern, pattern language, is that like akin to Gang of Four pattern language, where they're talking about
right.
patterns as a way to communicate common ways of structuring algorithms or tasks?
Okay, so is this like design patterns, the Gang of Four book? I have the Gang of Four book. Yes, it is, and it's different as well. Yeah, the Gang of Four book, the patterns, design patterns, I think that was either the first or the most famous about this is how you design the patterns, with examples in Java, but it's language independent. Those patterns are just like mine. They're inspired by the architect, Christopher Alexander, and when he used patterns in architecture, and he created a pattern language. He also spoke of creating patterns and pattern languages and how you might do that, or what the requirements are. And yes, that is the Gang of Four book about design patterns. It's using the trend, the idea, we call it a meme that Alexander started, and applying it to software, running software product. The MetaAutomation, the pattern language, is 7 patterns. And the patterns are, in a sense, like the Gang of Four patterns because they describe common solutions to common problems in a context. It's also a pattern language, unlike the Gang of Four book. The Gang of Four book is a large set of patterns, but it's not a pattern language. MetaAutomation is a pattern language, and I'm really glad you asked that question because it goes right into the next slide here about the pattern language. So this diagram is on MetaAutomation.net, and there's a lot of stuff here, but I'm going to discuss the whole, and then we'll zoom into different parts. This is MetaAutomation, the pattern language, as currently discovered. It's 7 patterns. Each of those blue boxes is a pattern, and then there's one hierarchical steps is embedded down in the lower left. I'll zoom in there in a second. It's a pattern language because it's a solution to a problem in a context. And the context is here. I mentioned the business, the software business that is concerned with making your software project and shipping it. So that includes ICs in the QA, quality engineers. It includes the devs. It includes PMs and all the managers, and even the executive branch. They benefit from this too, and I'll mention that a little later. That is the upper boundary of the pattern language, the context of the pattern language. Down here is technology facing, and so this is driving the product and making measurements of the product. This is what you already do. With an automated verification, you are driving and measuring the product. So I've just formalized it and form a context for the pattern language. So maybe this completes the answer to your question. MetaAutomation is a solution to a problem domain in a context. The problem domain is quality automation. As I mentioned, quality automation is an ideal. I guess I call it that to try to isolate myself from any criticism, but also MetaAutomation is just an implementation of quality automation. And it may not be the only one, it's the only one I know of, so I guess it's the only one known, but this is the pattern language. And I'm going to zoom in down here to the technology-facing steps, part of the pattern language. Patterns to drive and measure the product. So this is the boundary here between, say, code that QA would be responsible for and your product, which you're actually going to ship, or maybe you already have shipped it. This is the boundary. Patterns to drive and measure the product, make the product do stuff, and make measurements on the product. And with hierarchical steps, there are handy placeholders for any instrumentation of the product you want to put in there. You might even populate those asynchronously to improve the quality of the data. Hierarchical steps is that pattern that I mentioned before. Basically, this is a radical departure from the conventional way of doing things because conventionally we have logs, like I showed in Paradigm Shift 3. We have logs in our automation. With hierarchical steps, we are able to handle a report on the complexity of what we're doing with a product. You can't do that with logs. I'm convinced you cannot do it. The hierarchical steps, partly because it's a natural pattern, partly because you need it, can report on the very smallest steps of what it is you're driving your product. Also the dependencies, like network dependencies, or you have other external dependencies, database dependencies. And all these are in the hierarchical steps pattern, which is embedded inside atomic check. So atomic check roughly corresponds to an automated test. And it's about the ideal way to do it. Atomic means as small as possible while still verifying your functional requirement, your specification. And really there's a one-to-one mapping here, or there should be, ideally, between a specification that we can define, one of the many specifications, this could be a boundary condition even, and your verification for that specification goes into an atomic check. The check part is, again, that we know that this is not a manual test, and we're not Terra, and we don't know about anything because we're not smart. All we know about what's in the code, mostly for verifying. Atomic check is the fastest way to do it. Oh, another thing about the atomic check pattern is that it must be independent of all the other atomic checks. So all the atomic checks are independent of each other, so they scale. Does anybody run automated tests and manage their test environments separately from the automation itself in their infrastructure? So you manage environments over here, you manage your checks over here. If you manage those separately, I know some people do, then you're using Precondition Pool because you consider preparing an environment and making it ready to run the test. That is a precondition. So what I've done with Precondition Pool is just generalize their paradigm. The preconditions for the test could include the test environments that you use to run the check. It could also include users or services or documents or anything else that you want to manage. It can be done asynchronously and independently of the check itself. And the reason I do that is Precondition Pool makes atomic check, or what you can implement for the atomic checks, simpler and faster. And because they're simpler and faster, the quality of the data coming out is better. It's more valuable to you as an expression of product quality. There is, less noise going on, or less stuff that you don't really want to worry about.
Is there a connection between the precondition pool and the atomic checks? Because typically, when I think of the automated testing that I do, typically you'll have a certain set of atomic checks that are dependent on a particular precondition in the precondition pool. They're tied, right?
That's a great question. So the question is there a dependency between a precondition pool on atomic check because different checks need different precondition objects? And yes, there is, and that's a great question. In fact, I skipped over it, and thanks for reminding me, because so this diagram shows some dependencies with the black dashed lines. Part of what makes it a pattern language is that it has an ordered dependency. There are many more dependencies than I show here in the diagram, because if I showed them all, it would look like the New Jersey Turnpike. And so this is the simplified version of the diagram. So for example, there would be a line from here to here. Probably the precondition pool depends on atomic check because they have to run pretty fast. In a sense, you could say atomic check would depend on precondition pool. In another sense, though, you can implement atomic check without having precondition pool implemented at all. In fact, I have in the samples. Precondition pool is not implemented. No, okay, I'm wrong. Precondition pool is implemented in the samples in terms of the environment in which the checks run. But I guess, the dependency, I guess, goes both ways in that sense. In any case, I would be very busy to show all the dependencies, so I don't actually show it there. But does that answer your question then? Yeah. Okay, so I'm going to zoom out here. Patterns to speed the checks and improve the data value. So how many people, when they run their automation, allocate different virtual machines to run it on? Or they have it run it on parallel machines? Yeah, a bunch of you, right. That's parallel run. Very simple. And I've just formalized it and tried to define the dependencies around the patterns. Basically, we can allocate a number of environments. Because they're atomic check, they're all independent of each other, it means we can scale massively, which is important because when we write this code to test the quality of the product, if it's a product that's going to be around for a while, we know that the work that we do in automating the product, that's going to be around for a while too. If it's going to be around for 5 or 10 years, we know that the VMs that we allocate out on the cloud they're going to be a lot cheaper 5 years from now. And so we will want to scale. And that's why atomic check is so important. I mean, not just scaling now, but in the future. This is my favorite. Okay, maybe not my favorite. It's just the coolest pattern because it solves the flaky test problem. Smart retry is about retry for checks that fail, but it's smart about it. Now, how many of you do you use a retry pattern? Anybody? Somebody use a retry pattern? Yeah. There is a retry pattern. So it's basically if the check fails, run it again, see if it passes. Right. Do you run it more than twice?
We do 3 times.
3 times. Okay, 3 times. Yeah. That's great. That adds value. Please don't be offended when I tell you, I call that the dumb retry pattern because you don't know why you failed. You don't have information on that. Before this came along with hierarchical steps and you're keeping track of all that stuff, now you do know why the check failed, or at least from the point of view of driving the product, you have a lot of information about root cause of failure, which means smart retry can be smarter about it. You have to configure it, the system, to look at the stack trace and look at the step in the hierarchy that is the root cause of failure. Yes, the failure propagates up through the hierarchy, but there is a step in the hierarchy that is closest to root cause, and find out, hey, do I want to retry this or not? So for example, the failure could be to a timeout in an external dependency, and the step and the stack trace tell me it's an external dependency. I do want to retry in that case. If I reproduce the failure, then probably that notification would go to whoever wrote, the engineer that wrote it or the team that wrote it, because you might want to increase the timeout. I'm a little bit ahead of myself here, but let's suppose the stack and the step suggest that, no, actually this is product code, and here's some failure within the product code. I don't know what this is. Maybe I want to retry or not. Whether or not I retry, the data is all there for later analysis. But probably, if I retried, it would find out whether or not I reproduce the failure. If I don't retry, it's because I don't want to run any risk of hiding the fact that this just failed. Although all the data is going to be saved anyway. This is XML. It's pure data. It's compact. No presentation in there. Very compact. We can store it for a good long time and do all sorts of robust analysis on it. But Smart Retry will tell you if I just reproduced that failure. And that's probably actionable by somebody. It could just be in the test code. We have to increase the timeout. Or we have to rejigger the way we wait on certain objects in a GUI, for example. Or it could be I just reproduce the failure in the product. Whoa, this really looks like a bug. And now you can send it to the developer, and the developer knows that I have reproduced this failure. And so that's what Smart Retry does this for you. Because all the information about your root cause from the point of view of driving the product is there. Plus, you can put in more information about product instrumentation if you want to. They're the perfect placeholders for it because it's all XML. I wish I had time for a demo, but I do not. I'm going to ask people to use the samples on the MetaAutomation.net, if you can, and play around with it. I'm actually quite proud of the code. It does a lot of cool stuff that I can't even go into here because I don't have time. But that's Smart Retry. So it's about improving the quality of the data. It's also about not interrupting your day if this test timed out again because you didn't set a timeout long enough, maybe, but it's not critical right now. But under the retry, it passed. So you don't have to worry about it. Okay, this is the business-facing interfaces. So quality over time is about pull. I'm going to go to an internet site and run queries and analyses and stuff because all the data is there. Automated triage is about directed notifications. I mentioned having the stack trace and the root cause of failure right in the check means that I can probably find a responsible party and direct an email or whatever notification to that person, and maybe a distribution list as well. So these patterns present the quality information to business. But so far, Otto the automaton is doing all this stuff for you. After the engineers have configured the system, nobody needs to get involved yet. So think of all the time that's been saved, and think about how much more attention you're going to pay if you only get an email from this system every third day, and it's like, oh, I'm responsible for this. I have to fix this, versus, well, we have a folder in Outlook, and here's where I put all the emails that come from the QA, and there are lots of them, and I hate looking through it because it's so much junk from my perspective. Now, it's more actionable. So I'm going to zoom out again. This diagram is on MetaAutomation.net. I'm not going to promise that it won't change. I do promise that it will be in the 3rd edition of the book. And that reminds me, I owe you a book for that good question. I'll sign it at the end if you want. I have another one. Nobody's asking questions. Okay, I think we need to move on, though. MetaAutomation solves these problems. Slow checks, because now they're ideally fast. Lots of different ways of making them faster. Flaky checks solve that problem. You can make them actionable. It doesn't eliminate flaky tests. It does make them actionable. Ignored failures because you have root cause. Is there a question?
Yeah, with the smart retry, I mean, I agree it like helps us like move forward and so on and so forth. But like, do you think that like it like kind of hides, like what I've noticed at least with us is it kind of hides ugliness of code in the test itself, like because you'll see like which ones failed and you can go in and see it, but like it doesn't necessarily encourage the developers to go in and look at it because everything's green, everything's moving forward.
Oh, right. Okay, so, and I hear you both. So the question was, does smart retry hide the ugliness? And would it discourage anybody from looking at root cause of failure? Well, this is about a different kind of a process. I mean, yes, when you see the green, I mean, traditionally, you see the greens, I'm happy, I can go on and do whatever else I was doing. But all the data is there, and with smart retry, it does not throw any data away. You still have the information, and there may be a failure there, and depending on the root cause identified, it might be actionable. And so it's a matter of team process and saying that, well, we can still find, at a lower priority, maybe, find who might be responsible for the issue which may or may not be there indicated by this transient failure. Does that make sense? So I'm not hiding the data. I mean, the idea is you have to change the procedures so that if you see green, you think nothing else matters. Because we're moving beyond just the pass-fail result. And now we have all the information on what the product is doing. So it's not hiding any information. It's all going to be stored. And it's all available for analysis. Now you can look in the hierarchy. Let me see if I put this in. You can look in the hierarchy and see for the steps, how many milliseconds did this step take? And if this step is reused, how fast is it on average? Did it ever fail, or how often did it fail in the last month? What's the trend of reliability over time? Or what's the trend of performance over time? And are there outliers and all that? You have all that data there, including even with the ones that are failed and end up as green in the end. Okay, so we know ignored failures. They don't get ignored. Secret QA knowledge. One thing that concerned me when I was implementing this is that with keyword-driven development, or if you're doing even BDD with Gherkin, you have to implement keywords. So your QA has to implement keywords. Nobody knows what's in that code. If you don't go in and step through at runtime, you really don't know. What I've done is implemented self-documenting check steps. They document themselves at runtime, so there is no secret QA knowledge. It's all there in the XML and presented nicely on an internet page. Everybody knows what's going on. You don't have to document test cases anymore. And I know people disagree about this, but in my dream is that you don't even need test cases, because when it's automated, you have it self-documenting. For the stuff that cannot be automated, that's when you need Terra, and you need exploratory testing anyway. Underappreciated QA role. So I hinted at this earlier. The QA team are now like the heroes of the team because they unify everybody. They bring them together. They get the communication we have with the product information, that's always available to everybody. So now we know what QA is doing. I mean, they've implemented all this stuff, and they're maintaining it and maintaining the system so efficiently it portrays exactly what's going on with a product. The devs can use this to be more productive. They can do end-to-end and gated check-ins or bottom-up check-ins with this information. They can do it faster than they could before. I'm going to get to SOX compliance in a second. Okay, performance checks are in there, in line. And now you have all the performance data there. You can also do stress and failover tests and all that stuff, but you can reuse this code to do it because all the performance information is there in the XML element. Cross-geography, trust and respect, potential factor for miscommunication is no longer there because now we know exactly what the product is doing. And there's much more clarity into what people is doing. And SOX compliance, again, it's Does anybody remember Enron? Enron, good came out of that though. Sarbanes-Oxley, it's transparency into the assets of a publicly traded company. One thing that, in fact, a CEO of an Oregon startup turned me onto this. He said, this is great for SOX compliance because I have great visibility into the quality of my software. And for a software company, that's an important asset. So QA team can help promote the good valuation of the company. That's cool stuff. The team is happy, so unified. I think we have to break for questions at this point. Because we have just a few minutes left. Yeah, question.
My question is kind of with this, we're working with a real-time operating system, a real-time system that requires an operator, not a lot of data. Is it possible to have the precondition pool actually be your atomic tests? So that way, I want to test this, the precondition is I have to go through these steps to get to that point.
Huh. It kind of already is. The question is, can I use precondition pool to do my atomic check? I guess you could. I'm not sure why you'd want to, though, because the precondition pool becomes the atomic check pattern at that point, right?
Well,
I don't know.
We're looking at more from an operator standpoint. Each operator can get onto the system and do something different with it.
Oh,
is that we don't actually have data in the
oh,
background.
okay.
We have a real-time system that for controlling vehicles, C2 in a vehicle.
Yeah.
And
cool.
we want to try to, I'm kind of looking at some ways of trying to automate the ability to do that, but from the standpoint of not creating just these long, test cases that go through step 1, step 2, step 3, step 4.
Oh, right.
It'd be really great to sit there and have the automatic test, be able to sit there and say, hey, this is what I want. Before I get there, I have to do X, Y, Z, before I get to that point. So to have previously run atomic checks as part of the precondition pool for the current atomic check that I'm currently working on.
Right. I don't think I have enough information on your system to answer that question about which pattern you would use, and maybe it would be a combination of both. But it sounds like your application is an ideal thing where you do want a short and simple check, and this basically discusses that as a value and the benefits that you can get. For a real-time system, I never thought much about applying this in a real-time system. I think it's certainly it work, but the test conditions might be interesting. I've implemented this in C#. Yeah.
Yeah. The thinking things you need to do to get to the point where it's
The state you need to be in, yeah.
yeah, that's your precondition, and then the check is, and the light comes on. Right?
Yeah,
So
okay.
that's the atomic
Yeah.
check.
Well, I keep in touch because I'd really like to know if this helps with that in the solution that you come up with. So the atomic check and the precondition pool are a little bit complementary. Actually, the atomic check might end up looking like, the precondition pool might end up looking like an atomic check anyway because you are doing similar operations or maybe doing similar operations. And you can have still self-documenting checks. You may also have failures that you need to follow up on. So actually, there's some of atomic check and precondition pool in that sense. So, other question? Yeah.
So I've got a range of loose DevOps running around in my servers. And I'm curious about which patterns might be valuable in having whether it's in the automated triage or just in the precondition pool and stuff, about finding and detecting where someone has decided to spread a tuning or a patch or made some update sort of outside of my context.
Oh, okay. So
I've got a very, very integrated system.
cool. So let me see if I understand your question. It's because you want to apply some of these patterns not to automated verifications, but to DevOps operations,
in
right?
the context of, so I want to run some, really some application level quality automation, but I'm curious about which patterns might help, because outside of that context level, there's also other changes going on.
I can't answer that question. It's about DevOps and so on. Sorry, about quality changes and yeah.
Overlaps, and so people can mind is outside of our
I would love to talk with you afterwards about the problem. It's about, it sounds like more a DevOps problem, which is not my core of expertise. But okay, please do the evaluations when on the app, because that's very helpful to me personally and to PNSQC. The book I'm sorry, I'm going back to the end here. There, yes. Oh, I missed that one. Okay, well, we'll have to discuss it later. And okay, that's the current edition of my book. The third edition will be a superset. A target is February. So my email address, matt@metaautomation.net. The samples are in metaautomation.net, including that one of the pattern language. Please do the evaluations and keep in touch. I want to know if you guys can find this beneficial in different industries. I will learn from that, and I can improve what will be the future version of my book, probably, with that. So it's very helpful. Yeah? Question?
So you mentioned parallel runs.
Parallel run.
So does the software schedule the parallel runs? Like, so there is a database?
Right. So the question was, with parallel run, does the software schedule when well, there's oh yeah. Well, the systems might schedule when the checks run. I assumed that if you had a set of checks and you started a check run, you would run them all across the different machines, but basically sequentially. But you could do that differently if you wanted to. You could have it scheduled any way you want, like with a job tool. You could run them that way.
The software, like you asked us to download, so I looked at your website, and there's a software sample, so the sample
Yeah.
does actually schedule the run. That's my question.
Oh, yes, it does. Yes, the software is very simple the two samples. The first sample is easy to install and run, and it all happens on one machine, multi-process. I have checks which cross many processes. There are multiple checks per enabled. There's a great document there which shows you how to run all this stuff. The second sample will run across any number of machines depending on how many machines you install it on, and that's a bit of work. And so I have extensive documentation on that. So the second sample, which is the one that you want to run if you're doing Internet of Things, but I would still recommend running the first sample first because a lot of the stuff is the same, and the first sample is a good introduction. I think the answer to your question is that either sample will schedule the runs whenever you start, and it'll run them all across the whatever of machines that you have allocated to do that. So, the question? Yeah.
On your website, you showed the diagram of your 7 patterns.
Thank you, everyone. Be sure to fill out the survey.
Whoa. It's because, thank you. It's because you have an old version of the website.